Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today we are going to be reviewing for the Chapter 11 test, which is tomorrow. So a couple of things. I will be back this afternoon at 1:15 for my office hour. Tomorrow morning we will not be having a class session. It's just up to you to complete your Chapter 11 test tomorrow before 11:59. After that, have a great Thanksgiving. And there's no class on Wednesday or Thursday or Friday. We'll be back next Monday, and we have a full week that week during which we will be reviewing for the final exam. Monday, I believe I'll start with reviewing from the very first test you took, which is over, let's see, graphing systems of inequalities, and then Chapter 14 having to do with, let's see, what was it? Arithmetic and geometric sequences, I believe. And let's see what else, factorials. Anyway, enough of that. Let's get on to our questions today.
Hey, Mr. Mayo,
Yes.
I have like a quick question just before I forget.
Sure.
So our final is on December 7th, yes?
Let's see, let me check the calendar. Yes, it is.
Okay, how many oh yeah, it's 30% of our grade, right?
Yes.
Okay, how many like questions will it be? Like, will it be a lot more than it?
No, it'll be about like taking 2 tests. And I think we have like 3 hours, so.
Okay, I was gonna ask if we had the same amount of time or.
Yeah.
Okay.
You have longer because yeah.
Okay, thank you.
You betcha. All right, any other questions before we get going on answering your questions that you've texted or emailed me rather? Okay, so first of all, this is from section 11.7, and this is number 10, which I will show you on the web assigned screen. Okay, it says, in 4 years, 20% of a radioactive element decays. Find its half-life. All right, so the formula we're going to be using, the half-life formula, is A equals A sub 0 times 2 to the negative T over H power. And then we've got T, H, A sub 0, and A. Now, 4 years is the time. The half-life is the unknown that we're trying to find. We don't know the original amount, so that's just going to be A sub 0. Now, here's where we need to be careful. It says in 4 years, 20% of the radioactive element decays. So 20% goes away, which means there is 80% left. So the final amount, A, equals 80% of the starting amount. A common mistake here is to put 20%, but 20% goes away. So what our situation looks like is this, what you see on the whiteboard. Okay, so plugging all that into the formula, we get 0.8 A sub 0 equals A sub 0 times 2 to the negative 4 over H power. H being the half-life, being the unknown. All right. The next step, we're going to divide both sides by A sub 0, which gives us 0.8 equals 2 to the negative 4 over H power. We're trying to solve for H, which is part of the exponent. So to isolate that, we're going to change this exponential equation into a logarithmic equation. So this becomes log base 2 of 0.8 equals -4 divided by h. Well, we're trying to solve for h, and h is in the denominator on the right side of the equation. We need h by itself in the numerator. So the next step we're going to do is we're going to multiply both sides by h, which will give us h log base 2 of 0.8 equals -4. Well, now we've got h on top, but it's not by itself yet. So we're going to divide both sides by log base 2 of 0.8. So now we've got h equals -4 divided by log base 2 of 0.8. So we've solved for h. However, we still have a problem. Log base 2 of 0.8, most of us can't put that in our calculator unless you happen to have the change of base button built in. If you do, it looks like this. It's got log, and it's got a box there, and I think a box there like that. Okay, but most of us probably don't have that. So then h is going to be equal to -4 divided by log of 0.8 divided by log of 2. Okay. And I'm going to quantify that entire denominator. So on my calculator, I'm going to put in -4 divided by parentheses log 0.8, close that up, divided by log of 2, close that up, and then close up the entire set of logs. And I come up with 12.425, etc., rounding to the nearest tenth, 12.4 years. So again, on my calculator, I had that in terms of all the parentheses. Any questions about that before we go on? All right. Let's see here. Next up is problem number 12. It says an isotope of lead has a half-life of 8.4 hours. How many hours ago was there 70% more of the substance? Round your answer to 1 decimal place. Okay, let's see. This is number 12. We're still going to use the same formula. A equals a sub 0 times 2 to the -2 over h power. We've got t, h, a sub 0, and a. Let's see. The half-life is 8.4 hours. So h is 8.4 hours. How many hours ago? So the time is the unknown. How many hours ago was there 70% more of the substance? Okay, so now things are a little bit trickier because we're kind of going backwards. So A, just plain old A, is the ending amount. So A equals A. A sub 0, it says it had 70% more of the substance. So A sub 0 would be 100 and 70% of A, or 1.7 times A. All right, so now take a look here. Any question where I got the 1.7 before we go on? All righty, so then our equation becomes A equals 1.7a times 2 to the -t over 8.4 hours. We'll divide both sides by a, so 1 equals 1.7 times 2 to the -t over 8.4 hours. Well, let's see here. Actually, you know what I should have done? I guess I can still do it in 2 steps. I need to get rid of that 1.7 on the right side as well. So I'll come back and do it now. So 1 over 1.7 equals 2 to the negative t over 8.4 power. And 1 over 1.7, I'm just going to kind of clean that up. If I take 1, let's see, 1 divided by 1.7, I get this big, long, nasty looking thing. What I could do, just to clean it up a little bit, I'm going to multiply it by 10 over 10. So then it becomes 10/17 equals 2 to the negative t over 8.4 power, just to make it into a nice fraction. Now, I'm going to change it into a logarithmic equation to isolate the exponent. So we get log base 2 of 10/17 equals negative t over 8.4. I'm going to multiply both sides by negative 8.4. So that will get rid of the 8.4 and the negative on the right. So I've got t on the right, so I've got t equals negative 8.4. And then I'm going to use the change of base, log of 10/17 divided by log of 2. Okay, so on the calculator, negative 8.4 log of 10/17, close that up, divided by the log of 2, and I'm getting 6.43, etc. hours, rounding to the nearest tenth. T is 6.4 hours. Any questions on that one before we go on? Okay, then let's go to the next one, which is number 13. Again, we're still in section 11.7. If $500 is deposited in an account paying 8.7% annual interest, compounded semi-annually, how long will it take for the account to increase to $800? Now, the key here is that it's compounded semi-annually, not continuously. So the formula that we're going to use is A equals P times the quantity 1 plus R over K, all raised to the KT power. So we've got P and A and R and K and T. It says $500 is deposited, so that's P, in an account paying 8.7% annual interest, so that's R, 8.7% or 0.087, compounded semi-annually, so K equals 2. How long will it take for the account to increase to $800? So A is $800 and T is the unknown. All right. So we've got all of our information. Let's plug it into the formula. We get $800 equals $500 times 1 plus 0.087 divided by 2, all raised to the power 2t. Okay, and our unknown is t. Well, let's see here. What can I do to simplify things? 0.087 divided by 2 is going to come out nicely. Let's see. So that would make this $800 equals $500, 1 plus, let's see, 0.087 divided by 2 is 0.04 2t all raised to the 2t power. And that's going to be $800 equals $500 times 1.0435 to the 2t power, because 1 plus 0.0435 is 1.0435. Okay, well, I've done all that, but I've still got to, get t by itself. And to do that, I'm going to have to change this into a logarithmic equation. But I can't do that yet because I've got this extra number out here. So what I'm going to do is divide both sides by $500. Okay, let's see. On the left side, that'll give me 8/5. And on the right side, I get 1.0435 to the 2t power. Now, 8/5 comes out to 1.6. We can go with a decimal. We could leave it as a fraction. I'm just going to leave it for now. So now I can change it to a logarithmic equation. So I'll have log base 1.0435 of 8/5 equals 2t. Let's see. I could divide both sides by 2 or multiply both sides by 1/2. Let's see, I'm going to do that. I'm going to multiply by 1/2. So that gives me t on the right. And I'm going to take that 1/2 on the left and I'm going to change it to 0.5. It'll just make it easier to put into the calculator. So I'm going to get 0.5 log of, change of base. So 8/5 divided by log base 10 of 1.0435. So let's see what we get with that. 0.5 times the log base 10 of 8/5, close that up. Let's see, divided by the log of 1.0435, close that up. And I get 5.51, etc. years. To the nearest 10th, it would be 5.5 years. So there's number 13. Any questions there? Okay, back to the WebAssign screen. We're going to take a look at problem number 14. And again, we're still at 11.7. It says a sum of $5,000 deposited in an account grows to $8,000 in 6 years. Assuming annual compounding, what interest rate is being paid? Round your answer to 2 decimal places. Okay. Annual compounding. So again, we're not using continuous compounding. So we're going to use the same formula we used in this last problem. A equals P times 1 plus R over K to the KT power. And let's see, we've got P is $500. R is 8.7% or 0.087. K, oops, you know what? My problem, I've been looking at problem number 13 there instead of 14. Sorry about that. So let me write down the right stuff here. Okay, number 14. A sum of $500, so that's P, $5,000. I'm going to get this right yet. Deposited in an account grows to $8,000. Okay, so we know P and A in 6 years. So the time is 6 years. Assuming annual compounding, so K is 1, what interest rate is being paid? Round your answer to 2 decimal places. All right, so we know the beginning amount, the ending amount, the number of compoundings, and the number of years. Okay, let's see if I can get the right information here. So now our formula looks like this. $8,000 equals $5,000 times 1 plus R over 1 to the 1, let's see, the 1 times 6 power. I'm going to clean that up a little bit. Just going to write it this way. $8,000 equals $5,000 times 1 plus r divided by 1 would just be r, and the exponent 1 times 6 would be 6. So I've got $8,000 equals $5,000 times the quantity 1 plus r to the 6th power. Okay. Now, my unknown isn't an exponent, it's inside the base of that exponent. What I'm going to do next, I'm going to divide by $5,000. Okay, on the left, that will give me 8/5. On the right, it will give me 1 plus r to the 6th power. So let's go back to chapter 9. If we have an equation where we've got, let's see, is it chapter 9? Yeah, chapter 9. We could raise both sides to the 1/6 power. Okay, so now I've got 8/5 to the 1/6 power equals 1 plus r. See how that would work? Because the 6 and the 1/6 would reduce out. Now I'm going to subtract 1. So basically I've got r equals 8/5 to the 1/6 power minus 1. Okay. So on my calculator, I'm going to put in parentheses 8 divided by, I think I said 8. Yeah, 8/5. So 8 divided by 5, close it up, and then raise 2. So the little caret, parentheses 1 divided by 6, close it up. And then outside of that, minus 1. When I do that, I'm getting r equals 0.08148, etc., etc. Okay. Now, it says round your answer to 2 decimal places. If you look back at WebAssign, you will see that they've got the answer written as a percent, not as a decimal number. So that means we have to take this number and change it into a percent, which moves the decimal point over 2 places. So now r equals 8.148%, rounding to 2 decimal places. The 8 rounds up. So our final answer, r, is 8.15%. So that was a bit of a tricky problem, wasn't it? Yeah. Okay. Now, let's see. We're going to take a look at some chapter review questions. Starting with number 5. Okay. So this is chapter review number 5. Again, I had a lot of people ask questions. I may not be able to do every one for every person, but I'll try and do at least one of each one that's asked, and yours might just have different numbers. We'll see how it goes. Problem number 5. Assume that there are no deposits or withdrawals, okay, after the problem starts. So an account now contains $3,660 and has been accumulating interest at 4% annual rate, compounded continuously. How much was in the account 4 years ago? Okay, first of all, compounded continuously. So we're going to use the formula A equals PE to the RT power. Second of all, we're kind of going backwards. We know the final amount. So we know A, we're trying to find P, which was the original amount. So A is $3,660. P is the unknown. Interest rate, R, is 4% or 0.04. And T, time, is 4 years. Okay. So now, plugging the information in, we get the following. 3,660 equals P times E raised to the power 0.04 times 4. I think what I'm going to do next is I'm going to go ahead and I'm going to calculate 0.04 times 4. So that's going to be, let's see, 0.04 times 4. That's going to be 0.16. Okay, I'm trying to isolate P. Well, I'm going to divide both sides by that. So that will isolate P. So P equals $3,660 divided by e to the 0.16 power. So 3660 divided by second e to the x and e to the 0.16 power. And I come up with 3118.846. The 4 rounds up, so we get $3,118.85 for our answer. Any questions on that before we go on? Okay. Still in the chapter review. Now we're going to look at problem number 10. It says if $550 is deposited in an account paying 8.6% annual interest compounded semi-annually, so it's not continuous, how long will it take for the account to increase to $850? So since it's not continuous, we're going to use the formula A equals P times 1 plus R over K, all raised to the KT power. If $550 is deposited, so P equals $550 in an account paying 8.6% annual interest, so R is 8.6% or 0.086, compounded semi-annually, so K is 2. How long will it take, time is the unknown, for the account to increase to $850, so the ending amount, or A, is $850. Round your answer to the nearest tenth. Okay. So our formula becomes $850 equals $550 times 1 plus 0.086 divided by 2, all raised to the 2t power. This is very similar to one that we did from the exercises. I'm going to take 0.086 divided by 2, and that's going to give me this. I'm going to get 850 equals 550 times 1 plus 0.043, all to the 2t power. Then I can add together the quantities in the parentheses and get 1.043 to the 2t power. So now I need to divide both sides by $550. So on the left, the dollar signs go, the zeros go. If I take out a 5, I get 17/11ths. 85 divided by 5 is 17. 55 divided by 5 is 11. On the right side, 1.043 to the 2t power. We're going to change this to a logarithmic equation. So we get log base 1.043 of 17/11ths equals 2t. I'm going to divide by 2 or multiply by a half or multiply by, let's see, if I multiply by a half, then I get on the, let's see, I get t equals, but a half would be what, 0.5. And then using the change of base, log of 17/11 over log of 1.043. Okay, so 0.5 and then the log of 17/11 divided by the log of 1.043. And let's see here. Number 10. I've done something wrong here. Oh, I see what I did wrong. Okay, hang on. Let's see here. 1.043. This is going to be that, 2t power, log of that to that equals that, 1/2, 0.5. Oh, yeah, I see what I did. Right here, I should have put a division symbol and I put a multiplication symbol. That's the problem. That's what I get for not wearing my glasses. Okay, so now I'm getting the correct answer. 5.169, rounding to the nearest tenth. The 6 would round up 5.2 years. And I guess I'll put on my glasses. Okay. Next up, number 27 from the chapter review. And says, evaluate the expression. Do not use a calculator. If the answer is undefined, enter undefined. We've got the natural log of the square root of e. Okay. So that's log base e of the square root of e. Right? ln, natural log, log base e. We'll say that's equal to some unknown box. Now we'll take this logarithmic equation and change it into an exponential equation. E to the box equals the square root of e. But the square root of e is e to the 1/2 power. Therefore, the box equals 1/2. The answer is 1/2. Let's see, 36 is next. Okay, we good to go on? I guess so. Number 36 says, solve the equation e to the x equals 3. Give an approximate solution to 4 decimal places. So here we have an exponential equation. We're trying to solve for the variable, which is the exponent. So I'm going to rewrite this as a logarithmic equation. Log base e of 3 equals x. But log base e is natural log. So natural log of 3 equals x. Well, I can just punch that into my calculator, natural log of 3. And I get 1.098612289. It says to round to 4 decimal places. Let's see, that would be here. So 1.0986 would be the final answer. And that takes us to number 38. And number 38 says this. A wooden statue found in Egypt has a carbon-14 content that is 3/4 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? So we're going to use the formula A equals A sub 0 times 2 to the negative, oops. Come on, eraser. To the negative t over h power. And let's see. So we've got t and h and a sub 0 and a. Wooden statue, blah, 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 blah. How old is the statue? So t is our unknown. half-life is 5,700 years. Now, it says the wooden statue found in Egypt has a carbon-14 content that is 3/4 of that found in living wood. So the starting amount is a sub 0. The ending amount is 3/4 of a sub 0, which would be 75% or 0.75. So that gives us the following information. So A is 0.75 a sub 0. So 0.75 a sub 0 equals a sub 0 times 2 to the negative t over 5,700 years power. Divide both sides by a sub 0. 0.75 equals 2 to the negative t over 5,700 power. Change it to a logarithmic equation. Log base 2 of 0.75 equals negative t over 5,700. Multiply both sides by negative 5,700. And then we get, let's see, the 5,700s go, the negatives go. So t equals negative 5,700. And I'm going to use the change of base, log of 0.75 over log of 2. And we'll go to our calculator. And we've got negative 5,700 log of 0.75, close that up, divided by log of 2. And we get 2,365.713746. It says round your answer to the nearest 100 years, which would be there. So that would round up. So it would be 2,400 years. Okay, now let's see. 10, 12, 14. It looks like we did all of those from a different assignment. Chapter review. Okay. As I said, I won't have time to do everything for everybody, but I'm going to try and do the most I can. If you still have questions, either come back during my office hour or email me, and I will try and get to you as soon as I can. Let's see. Oh, that's not the right thing. I want this one. Here we go. All right, and then yeah, I don't think we've done that one yet. So this is back, this is the chapter review. Okay, so chapter review, and this is number 12. Yeah, we didn't do one like this yet. Okay, so the value in dollars of a certain model car is given by the function v of t equals 17,000 times the quantity 10 to the negative 0.165 t power, where t is the number of years from the present. Find the value of the car in 4 years. So basically, they want us to find v of 4. So v of 4 is 17,000 times 10 to the negative 0.165 times 4 power. And let's see here. Negative 0.165 times 4 would be negative 0.66. So V of 4 is 17,000 times 10 to the negative 0.66 power. 17,000 times 10 raised to the negative 0.66 power comes out to 3,719.194. It says round your answer to the nearest dollar, so it'd be $3,719. All righty. Next up is number 23. I don't think we did one of those. So let's take a look. Again, chapter review. Number 23 says, if $11,500 accumulates interest at a rate of 8% compounded continuously, how much will be in the account in 60 years? So since it's compounded continuously, we're going to use the formula A equals PE to the RT. P, the starting amount, is $11,500. R is the annual interest rate of 8% or 0.08. And then T is 60 years. Okay. So A equals $11,500 times E raised to the 0.08 times 60 years. So A equals $11,500 times E to the, if I take 0.08 times 60, I get 4.8. So now 11,500 times E to the 4.8 power. And I get 1,397,369.801 rounded to the near 2 decimal places. Let's see, we'd have 1,397,369.80. Okay. And let's see, that takes us to 34, which I believe we did not do before. Okay. So it says the height in inches of a certain plant is approximated by the function h of a equals 15 plus 20.04 natural log of a, where a is its age in years. How tall will it be when it is 25 years old? So we want to find h of 25. So that's going to be 15 plus 20.04 natural log of 25. So on the calculator, 15 plus 20.04 natural log of 25. Be very careful that you push the right log button. If it's LOG, don't push the LN button. Okay, and this comes out to 79.506. It said round to the nearest inch, so the 5 would round up and we would get approximately 80 inches. Okay, let's see. We did 38. 23. 10, 11 and 12. Hang on. Okay. So make sure we're on that screen. And we're going to do okay. 11.7, number 9. 7, number 9. Again, I'm trying to do at least one of each example because there were a lot of questions. Okay, so we're looking at, this is 11.7, problem number 9. It says the half-life of tritium is 12.4 years. How long will it take for 30% of a sample to decompose? So we're going to use A equals A sub 0, 2 to the negative t over h power. We know that the half-life is 12.4 years. How long will it take for 30% of the sample to decompose? So we're starting out with A sub 0. A, the ending amount, since 30% decomposes, the ending amount is 70% of the starting amount. Okay? So we've got this situation. 0.7 A sub 0 equals A sub 0 times 2 to the negative t over 12.4 years. We'll divide both sides by A sub 0. 0.7 equals 2 to the negative t over 12.4. Changing this to a logarithmic equation, log base 2 of 0.7 equals negative t over 12.4. Even though I don't know that we did this specific problem, we certainly did one very similar to it. So multiply both sides by the negative and the 12.4. T equals negative 12.4. I'm going to use change of base formula. Log 0.7 divided by log of 2. Okay. Negative 12.4 log of 0.7 divided by log of 2. And let's see, which one was this? This was number 9. We get 6.38, which rounds to 6.4 years. Okay, let's see. We already did 10. We've got time for one more. We'll do number 11 on this same, let's see. Yeah, number 11. Okay. An isotope of thorium has a half-life of 18.4 days. How long will it take for 82% of the sample to decompose? All right, so A equals A sub 0, 2 to the negative t over h power. How long? So time is the unknown. Half-life is 18.4 days. How long will it take for 82% to decompose? So we're starting off with A sub 0. If we lose 82%, we have 18% left. So A is 18% of A sub 0, or 0.18 times A sub 0. Okay? So our equation becomes 0.18 A sub 0 equals A sub 0 times 2 to the negative t over 18.4 power. We divide both sides by A sub 0. 0.18 equals 2 to the negative t over 18.4 power. We change it to a logarithmic equation. Log base 2 of 0.18 equals negative t over 18.4. We multiply both sides by negative 18.4. We get t equals negative 18.4 using the change of base. log of 0.18 divided by log of 2. I know I'm going quickly, but we've done about 6 problems like this, and I'm running out of time. Negative 18.4 log of 0.18 divided by log of 2, and we get 45.52, which rounds off to 45.5 days. All righty, anyway, I tried to get through at least one example of everything. If I didn't get to yours and you still need it, either come at 1:15 or email me back and I'll get in touch with you as soon as I get a chance. All righty, have a great rest of the day. Okay,
Thanks, Mr. Mayo.
you're welcome.